The course that we are talking about here is called astronomical data analysis using Python, and it basically.
Could you elaborate on your journey, how you started at a BTech at IIT Bombay and then how you transitioned into a career in research? So do you think students who want to go into astronomical research or research of any kind for that matter, they should do a research degree at the undergraduate level, or they should start off with an engineering degree?
So the first part is I'm really excited by some research that I'm doing on high redshift galaxies with the James Webb Space Telescope.
So in countries like UK and USA, the security and defense aspect has always been an obstruction in allowing private partners to enter the field and make up satellites of their own. So do you think that companies in India also face such a hindrance launching satellites and telescopes in the Indian market as well as the market abroad? Good afternoon, sir. Thank you so much for joining this interview. I am Aditya Shankar. I'm a member of the New Delhi Space Society. And along with me, I have Ashwin and Rudranil. Ashwin is the president of the New Delhi Space Society. So we just like to thank you for taking out this time to sit with us for a while and have this interview. So if it's okay with you, can we begin?
Yes, absolutely. And thank you for inviting me.
Thank you so much. So first, for our viewers will be watching, I had initially done the course Astronomical Data Analysis by Python by a sir who's joining us, and that intrigued me, and I had done the entirety of the course. And so initially I planned to write an article for it for the NDSS, and while I was discussing with Ashwin, I thought it would be cool if we could arrange an interview with you. And so luckily that has worked out for us. So could you tell us a bit about your course for our viewers?
Yes. Yeah. So the course that we are talking about here is called Astronomical Data Analysis using Python. And it basically starts from scratch and teaches you Python programming in the first 5 lectures. Then it has a lecture on scientific programming with using the NumPy module. And then it has one lecture on plotting data. And then the last 3 lectures are focused on basically the application of all the Python knowledge that you have learned to real-life astronomical data analysis problems. So that's how it's organized. And we had a couple of tutorial sessions also. And this has become the most popular course on the NRC, National Resource Center that IUCAA runs in astronomy. It has become the most popular course on that particular platform. So that's the brief history. But if you ask for a longer history, I learned Python in 2002, and I've been using it almost exclusively since 2003. So I have a fair bit of experience, and I've been using it only in the context of software for doing astronomy. And so I have a lot of experience in that area as well. I have actually what has come about as this online course is the 4th iteration of this effort. I first taught a Python programming course in 2009 to members of my own institution. And then I did a couple of more iterations at 2 different locations. And finally, in 2021, we decided to come out with this course.
All right. Thank you so much. Do you have any plans for any further future courses?
There have been requests from time to time that we should have a more advanced version of this course. I have not given it very serious thought about what should be included and what should not be included in such a course. But there is a possibility that I could add in maybe 4 or 5 lectures, which would demonstrate some advanced applications of data analysis techniques. Perhaps even using some of the new generative AI technologies for writing software and so on. So I don't have any firm plans in mind, but there have been several requests from people to have a more advanced version of this course.
All right. So in your course, you talk about your journey from Fortran to C to Python. So do you think the people who are getting into data analysis for astronomy right now, they should learn Python, or should they focus on generative AI, like you said, or any other language?
Yes. So if they're getting into astronomy and they want to write code, I would strongly suggest that they start coding using Python. The generative AI technologies should not be used immediately. They are dangerous in the sense that if you don't know what you're doing, then it doesn't help you very much. So that's why they are often referred to as co-pilots. right? You are the pilot. The AI is the co-pilot. If you put the AI into the pilot seat, and then there will be trouble. So one should be very careful. So I would say Python. Uh, some of these, see, remember the real motivation for writing in Fortran and C, even up to this time, is the fact that these are compiled languages and are therefore very, very fast. So very often an approach is a hybrid approach is taken, even in many astronomical projects, where the part of the code that you need to run very quickly, this will typically be code that runs repetitively over many thousands or millions of iterations. That part of the code you rewrite in C or Fortran, and you do all the high-level programming stuff in Python. And it can be even done in an incremental way, which is that you first start with a full Python code. Then you do what is called profiling. So you identify the parts of the code that are taking up the maximum amount of time. And then you decide that, okay, this part of the code, if I rewrite in C, then it will move us. Many of the modern numerical computing libraries in Python are already written in C. For example, NumPy, which is the most widely used numerical Python library, that package is entirely written in C. Therefore, already it runs at native C-like speeds. So one should avoid the urge to do early optimization. One should write your code, make sure it's working correctly, giving you the right outputs for your inputs, and then do some profiling, identify the parts of the code that need to be speeded up, and then try to speed them up. And only you might end up just changing two parts of the code and realizing that, okay, I've got sufficient speed up. Now I don't want to spend my time getting a 1% or 2% improvement above this. I'll just run with what I have got. So I think this kind of mixed model philosophy is very important. There is no need to be like dogmatically attached to Python. Python has the advantage that it's very friendly to other languages. So it's very easy to write code, which is, let's say, C code or Fortran code, which is callable from within a Python program. So your main program is Python, but certain parts may call functions that are coded in C. And that approach works really well in my experience.
All right, that's highly insightful, if I must say. And one more question about your course. Who did you aim to be the primary audience or demographic of your course while you were making it?
Yes. So the primary demographic was PhD students in any astrophysics or astronomy program. It was more tailored to Indian programs and Indian students, but I have received email from people from various countries. Most recently, somebody from Greece wrote to me saying that they've done my course and they found it very useful, and so on. So there is always a tailor-made audience, and for me, the main target audience was PhD students in astronomy in India. And when I did a sort of market survey of the audience, I found that many of them had no exposure to coding before this. And that is why I did not start the course assuming that students know coding in Python already and then just do the astronomy part. What I assumed is that students don't know any coding at all. So that, I think that is part of the attractiveness of this course, is that it starts from the very basic. I mean, any high school student or anybody older than that will be able to follow along and do the course.
All right, great. Even I, as a high school graduate, did the course and I did not find any difficulty in following it. So I think if any of our viewers, they would like to start the course at their level, they wouldn't find any difficulty in that. On to our next question. Could you elaborate on your journey, how you started at a BTech at IIT Bombay and then how you transitioned into a career in research?
Yes. So my life story is a little bit complicated. I got first interested in astronomy in 1985, when news started appearing in newspapers that the Halley's Comet was going to arrive in a few months. All my reading revealed to me that it was 1985-86. It was going to be quite faint, would be difficult to see without a telescope. So then I said, okay, let me see if I can build a telescope. In those days, it was either impossible or extremely expensive to buy a telescope, but it was relatively affordable to build one yourself. So then I got in touch with someone who was building telescopes, And using their help, I built my own telescope. I started observing the night sky. Halley's Comet came and went, but after that, I continued to study the night sky on a regular basis. I joined the local astronomical society in Pune. It's called the Jyotirvidya Parisanstha. It's the oldest amateur astronomy group in India. And I was participated actively in their programs when I was in high school. Then later on, I wanted to know whether I could do a career in astronomy. There wasn't any really good undergraduate program in astronomy. So I decided that I would go do engineering and then switch to astronomy afterwards. So I'd sort of made that decision in 12th standard. And so I wrote my JEE and I went to IIT Bombay. I studied there for 4 years. And right after that, I came and joined IUCAA as a PhD student. And I did my PhD in astrophysics. That's the good thing about many of the Indian programs is that they accept students from engineering branches also into their PhD program. The only thing they require is that you should be sufficiently proficient in physics and mathematics to clear the entrance exam and interview that they conduct. So long as you are there, and I was fortunate enough to get a strong background in physics and mathematics through IIT. And so I did not find much difficulty in clearing the entrance exam, and then I joined IUCAA.
All right. So like you said, you started from engineering and transitioned to research because at your time there weren't many research opportunities available at an undergraduate level. But things have developed since the 1980s and 90s. So do you think students who want to go into astronomical research or research of any kind for that matter, they should do a research degree at the undergraduate level, or they should start off with an engineering degree?
It really depends on what your interests and skills are. Now, as you rightly said, there are plenty of opportunities. For example, a large number of ISERs have been opened up, Indian Institute for Science Education and Research. They're spread all over the country. And their focus is on scientific research. So I think it is certainly possible if you get the opportunity to go and study at an ISER, you can, and many of the ISERs also have active astronomy programs besides the other fields. It certainly is a good idea to go and study, get a solid undergraduate training in one of the ISERs. In our time, of course, that option did not exist. On the other hand, engineering is also an attractive way of getting into science because many aspects of science actually require engineering. So, for example, in astronomy, telescopes are our main instrument, and building bigger and better telescopes is fundamental to doing good astronomy. And therefore, if you are an engineer with a strong background in, let's say, electronics or optics, or even mechanical engineering and civil engineering in kind of subject, you are well placed to switch to a career in astronomy. In astronomy, there is a great dearth of people who can build instruments like telescopes and the back-end instruments that sit on them. So if you develop that skill as an engineer, then you will be much sought after during your career as a astronomer or scientist. And this, I think, I've given an astronomy example because that's what I'm familiar with. But this is true of other subjects as well. That if you want to become a good chemist, you may consider becoming a chemical engineer and then switching to chemistry. There are many examples of people who have done that.
All right. And like you said, you have a great insight into Indian academia. So could you comment on the current state of Indian academia? Because if you take a look at the current students and the youngsters who are about to go into college right now, they look down upon research because the remuneration in the field is quite low as compared to engineering and the placement offers that other colleges offer. So could you comment upon that?
Yes. So here, what weightage you give to the remuneration is what matters the most. It is certainly true that the amount of money you will earn in a scientific research career is going to be less than what you might earn if you go out and work in the industry. This has been true. This was true 30 years ago. It's true now, and it will be true 30 years in the future as well. So you have to keep that in mind. And this remuneration, the first question you should ask is the remuneration enough for me to lead a reasonably good life? Now, the answer to that is yes, provided you don't have to support members of your family. So, for example, if you are a PhD student, you will get a stipend that is sufficient for you to live a reasonable life. But if you say there are 4 or 5 people back home that I need to support, then it becomes really difficult. So that choice you have to make. But there are people nowadays who go for the high remuneration, even though there is no great compulsion in earning that extra money. That I think is unfortunate, because we are not getting good researchers because of this. They're very smart students who prefer a job which gives them a better salary instead of getting into research, although they are really interested in research. And so I know of some instances where people go and take up a job, they're getting paid a good salary, but they're not very happy there. So there are people who have left their job after 2 or 3 years and moved towards research. But many people don't. Most people don't. So what can be said? I can list some of the advantages of a career in research. In a career like astronomy is truly a global science. And to your audience, I suggest as evidence, you can look up on YouTube the proceedings of the General Assembly of the International Astronomical Union. So as we are chatting here, between August 6th to 15th this year, in Cape Town in South Africa, there is a worldwide meeting of all astronomers, and several thousand astronomers have gathered there, and all their talks are being live streamed on YouTube. This, I think, is a first, certainly for astronomy, and very like a first in all of science, where the sort of the top conference in the world for a particular field is being live streamed on YouTube for anybody to join and listen. So that is an advantage. You can collaborate with people from almost any country. And I have collaborators in about 10 countries of the world. Then you get to travel to many countries because you have collaborators in many countries. Conferences are happening in many countries. So you get to travel to several different countries. So these are the kind of advantages that one has, which cannot be quantified in terms of money.
All right, indeed. And as you said, you have collaborators from around 10 different countries. So could you please share insights about what is the difference between research in India and research in countries abroad? And are there any stark differences?
There are in the field of astronomy. Again, I will restrict my comments to the field of astronomy because that is something that I know very well. And the things may be slightly differently organized in other fields. In astronomy, the size of the Indian community is moderate. It's not very large. It's not very small. However, nowadays, what is happening in large international projects, that a lot of people come together and large groups are formed and they work on some challenging problem. In India, we don't have the scale to do that. So we find it very hard to work on the big problems, but we can still work on the niche problems. One advantage of astronomy is that because there is no profit to be made from the data, unlike in other fields, for example, genetics, where a lot of money to be made using genetic data. We don't have that possibility of making money using the astronomical data. So astronomical data is freely shared. So that is why collaborations are so easy. So if I know that somebody in France has some data which would be useful for my work, I just have to write to them and they will give me the data. Very often they would have put up the data on their website. So I don't have to even ask them. I can download the data, I can use it, and I simply have to acknowledge the source of the data and maybe I have to cite their papers, etc. But I can really gain access to the best data in the world. So that's the main thing. They have large groups. They're more well organized. They are doing larger projects, more ambitious work. Whereas we are doing niche things, things which are interesting, but something that can be done by 2 or 3 or 4 people working together rather than a team of 50 people.
All right. That's great indeed. And again, relating to that, I have 2 parts to the next question. Could you tell us which current research project you are most excited about? And for the first one that you are working on, and another that is happening around the world, which you may or may not be a part of, but really excites you.
Okay. So the first part is I'm really excited by some research that I'm doing on high redshift galaxies with the James Webb Space Telescope. The James Webb Space Telescope was launched in 2021, and since the middle of 2022, they have started releasing data in large volumes. Now, all these space telescopes have a wonderful policy that if you write a proposal to take some data with the James Webb Space Telescope, you can, it's only proprietary to you for a limited period of time. After that, that data becomes public, and anybody anywhere in the world can download and access that data. They give you the complete provenance of the data, which means how was the data observed, what were the conditions at that time, and so on. And they also give you software to convert that data, to process that data and to convert it into a usable form. So all of that is available. So I'm currently working on some high redshift galaxies, research which is currently under review with a journal. So I can't say specifically anything more at this stage. But overall, I think what excites me is the large number of new observatories that are coming online. And these enable things that you could not simply do before. So for example, if you take just again the JWST, this is a telescope that allows you access to extremely sensitive, high resolution observations in the near and mid infrared region of the spectrum. And you get very, very high quality data that is so sensitive that you can do some science which is not being done before. And in the field of high redshift galaxies, people are breaking every month almost the record for the highest redshift galaxy or the most distant or the oldest galaxy in the universe. That record is being broken almost every month with new data and high quality observations. So that is one. Then things are going to get even more exciting in the future, because very soon there is, by the end of next year, there's going to be a new kind of telescope called the Rubin Observatory, and they are going to run a survey called LSST, Large Survey of Space and Time. And what they're going to do is something that again has never been done before, which is they're going to observe the entire southern sky once every 3 days, 3 nights. And so twice a week, you will get 2 observations of the same part of the sky. And the primary science driver for this particular survey is to look for transients. Transients are objects that brighten and fade over different timescales in the universe. So they will search for those. They will also search for moving objects. But by combining all the observations that they will make over the 10-year period of the survey, one will be able to construct extremely deep images of a large part of the sky. And using that, one can even study static objects like galaxies, which don't change over time scales of years or decades. So those objects will also can be carefully and studied in great detail. So the numbers are simply staggering. Something like 19 billion galaxies will be observed with this survey, and a comparable number of stars. So it's really exciting time. And this is just happening in 2 years. And in 10 years, you will have next generation telescopes up. For example, in the radio, my institution is involved with the construction of the Square Kilometer Array Observatory. And that is going to be the next generation radio telescope. By the time it's operational in 2030, it will be the premier radio telescope of the world. And it will again allow us an exploration of parameter space that we have never explored before. And that's the beauty of astronomy. In most other fields, things are exciting for a 10-15 year period, and then things quieten down because now you're working on the details, but the broad picture has emerged. But in astronomy, because the universe is so big, it is all constantly throwing up newer surprises at us. We're constantly discovering new phenomena, or we're discovering new ways to interpret existing phenomena and so on. So it's an endless game. And that's what makes, to me, astronomy very exciting. Because as a field of research, there is always something to look forward to rather than just more of the same.
I agree. That does sound very exciting. Please let us know when your Redshift research gets released and gets published, because I'd be really interested in reading it. Could you tell us a bit more about the Square Kilometer Array that you mentioned?
Yes. So the idea behind any telescope is that you do try to increase the collecting area. Okay, so if you have a, let's say, an optical telescope, which is 1 meter in size, you try to build a 2 meter telescope because that will quadruple your area. Similarly, in the radio band also, you try to build receivers that can collect, you build more receptors so that you can collect more and more radio waves and make very sensitive observations. In the radio, we have another problem. It is because of the extremely long wavelength of the radio waves, the resolution that you get in your image is very poor. And in order to improve the resolution, we use a technique called interferometry and a technique called Earth rotation aperture synthesis. And together, these two techniques allow us to improve the resolution in the final images of the sky that we contain. So that is why radio telescopes are often spread over very large areas. And the square kilometer array will be actually two telescopes, one in South Africa working at higher frequencies and one in Australia working at somewhat lower frequencies. Both of them will have a large amount of collecting area. Both of them, in order to improve their resolution, will be spread over a fairly large area. The problem with building an observatory like this is that your improved sensitivity is only going to be useful if there is no other noise in the vicinity. So, for example, if in the middle of a city you build a big radio telescope, that's going to be useless because it is going to be dwarfed by all the radio noise that humans create. And by radio noise, I just don't mean things like the noise coming from our telephones, but also radio waves that get generated by a simple action like starting your motorcycle. If you start your motorcycle, there's a spark plug in there, there is a spark. And when that spark lights up, it also releases radio waves at a range of frequencies. So that can also damage your observation. So the radio telescope site has to be an extremely quiet site. You have to go to a place where there is no radio frequency at all, interference at all. And you have to actually mandate. So just like you have a sanctuary for wildlife, you need a radio astronomy sanctuary. And both the sites, one in South Africa and one in Australia, which will house the Square Kilometer Array Observatory, are extremely radio quiet sites and protected by law for the future. So this is a very exciting project. India has been involved with this idea since the very beginning. Just about a month ago, we officially joined the International Treaty Organization that runs this observatory. We are doing, our biggest contribution so far has been in the field of developing the monitoring and control system software for this telescope. So what we are developing forms the nervous system of the telescope. We will be able to control the entire telescope and make sure it's working at its highest efficiency.
All right, that does sound very interesting. You might be interested to know that I did my 12th class research project on telescope interferometry, but I did not know about the Square Kilometer Array, so this was quite cool to me. So bringing back our sights to India, with ISRO launching Aditya L1 last year, widening its horizons for astronomical research and data, which upcoming or potential ISRO projects that have been launched or will be launched do you think will be the most influential and useful to astronomical research?
Okay. So there are a couple of projects in astronomy, and again, they have not yet reached the approved stage. So I don't know whether it's appropriate for me to talk about them. In any case, I'm not an expert on these missions. But what ISRO does is that it sort of operates on one astronomy mission at a time, right? So first, they launched an astronomical satellite called AstroSat, which was a combination UV and X-ray telescope. Their next big mission is the Aditya L1, which was launched recently, which has a suite of instruments that have been designed to study the sun. It's called Aditya L1 because it's located at the Lagrange L1 point of the Earth-Sun system.
Of course, now these adjustments have now ensured its
closer to the sun
than
the Earth is, and it's in such an orbit that it stays in the same position relative to the Earth and the sun, even as the Earth revolves around the sun.
On the chromosphere
So
and
that is
corona.
their big
Its
mission. It has just been launched,
investigating
and
heating
all the solar astronomers in the Indian community
coronal mass ejections,
are strongly
and solar
involved
flares.
with
This milestone
trying
marks
to
a
use
significant achievement for
the
India's
Aditya
first
L1
solar
data
mission.
to the best possible extent and to try and do the most science that they could do with that experiment. Now, ISRO's current interests are now back back to Gaganyaan project, for example, they have a idea to put an Indian astronaut into space, and that is consuming their attentions. And there are missions to other planets which have been proposed, mission to Venus, more missions to Mars, even missions to the outer planets is in the planning stage. But I don't think it would be right for me to comment on the status of those projects, because they have long lead times, in the sense that even if they're approved, they will probably need 5-6 years before they're launched. So there isn't anything that is coming very, very soon on the astronomy side as far as ISRO is concerned.
Right. As you spoke about AstroSat, the NDSS actually organized a competition a few years ago where we had students come up with a successor to AstroSat. So we had some good submissions to that as well. Keeping up with the ISRO and India's space missions, India's Space Institute ISRO started very late compared to others such as USA and Russia, but it is still competing with them with the likes of Chandrayaan and Mangalyaan. So what do you think will be India's position in the space race 1 or 2 decades in the future?
Again, this is something that I don't have a clear view of because I don't have enough information. ISRO has been asking people to contribute to a roadmap. So what they've done is they've asked various stakeholders, astronomers amongst them, to suggest ways in which ISRO can help advance their field. But they have also gone to the earth sciences people and told them, how can we help you with remote sensing? They have also gone out to some of the other communications community and so on. So they are right now developing a roadmap for how they see ISRO contributing over the next 15, 20 years. And once that roadmap is published, again, we have given, as astronomers, we have given our inputs, and those will be folded in, and probably there will be some consolidated document that will come out. And you must remember that although ISRO is very active in the launch of commercial satellites and so on, ISRO does not have a large science division. It's mostly engineering focused. Their work is mostly focused on delivering payloads into the right orbit. So they are not, NASA on the other hand, for example, which remember has a much larger budget than what ISRO has. And therefore they can afford to have their own science division. And it is that science division which is funding or supporting all these big projects like the Hubble Space Telescope and the James Webb Space Telescope and others. So I think it's premature to say where ISRO stands in the race with NASA and so on. So unless their budget substantially increases, it will be hard for them to compete on that front. And also there is a lead time. Like if you start now, only in 15, 20 years will you reach a stage where you are internationally competitive in areas where you don't actually have strong competencies. So ISRO has, for example, strong competencies in the satellite launch market. So they are already trying to commercialize that effort. They have launched a number of commercial satellites already, and they will launch many more in the future. So there's a certain direction that they have set. There's a certain niche area that they're focused on. Astronomy is something that they've supported quite strongly, but it's still at a level which is very small compared to the European Space Agency and to NASA.
Right. So along with ISRO, the private space industry in India has also been rising very fast. So do you have any personal experience interacting with some of these private companies? And how do you think their work will benefit astronomical research here in India as well as abroad?
So one of the things that is very useful is radio technologies, for example, are multi-use. Okay, you can use a radio dish for receiving signals from the sky. You can use it for communication. You can use it as a radar for defense purposes and so on. So we are in touch with some of the companies which work on various aspects, all these multi-dimensional applications of the same technology. And on the radio, not just the radio dishes, but also the radio frequency electronics, the radio frequency data transport, the radio frequency, the radio data archiving, storage, data processing, all of these aspects are being worked upon by different private companies. The HA Observatory, whatever software we are developing, is being developed in partnership with software industry partners. So we actually have people from the industry who have come together, formed teams, and they are writing software. So we certainly have many avenues wherein there is this sort of public-private partnership where we interact with the private industry, get them to do things that we want them to do, and we also help them compete internationally. Because some of these things you have to build internationally in order to win the contract. So we are also in the process of trying to get the industries that we have gathered around us to be internationally competitive.
Right. So is there any company that you know that is specifically working on space telescopes? Again, you mentioned that ISRO does not have a huge science division. So do you think private partners could help catalyze that division of India's space industry and help speed up space research?
I don't know anyone who's trying to put up a large telescope facility in the country. So we have no equivalent of the private space industry yet. We don't have even the capability to build large satellites, which are extremely complex in the private sector. ISRO is doing it itself. Other space agencies are collaborating with ISRO to build very complex systems. But this is a work in progress. I mean, one must realize that the space industry in the private sector in India is very, very new. It's really only about a decade old or less. So it's only now that people are getting started. And it will take some time for us to discover our strengths, to build upon them, and to bring them to a level where we are internationally competitive with the private industry in the West. Private industry is very well developed. So, for example, many of the space telescopes that NASA launches, they're built entirely by private companies. So the blueprint is given to them. They're told exactly what to build, but the actual building happens in their facilities. And those completed telescopes are then delivered to NASA for launch.
Right. So the thing with astronomy and aerospace, for that matter, is it's closely allied with security and defense, right? So,
yes.
So in countries like UK and USA, the security and defense aspect has always been an obstruction in allowing private partners to enter the field and, you know, make up satellites of their own. So do you think that companies in India also face such a hindrance launching satellites and telescopes in the Indian market as well as the market abroad?
They could, because many of these technologies are restricted. So, for example, I'll give you a specific example. Infrared detectors, okay, which could be used, they're used in these night sight cameras. That technology was kept under wraps by law within the United States. And we astronomers really wanted access to that technology because we really would have benefited from using that technology. But most of the time, we don't get access to that advanced technology. And therefore, we can't build something to compete. So, for example, if somebody decides, I will build my own version of the James Webb Space Telescope, you can't, because you don't have access to many of the technologies that are used within that telescope. And because these are like sort of, again, big budget problems, big budget telescopes, one cannot hope to gain access except through licensing or through outright purchases of many of these technologies. It's not a very easy game that you simply go and say, okay, let me build a complex satellite like the Webb telescope, and it's just not possible.
And that's true. So we don't want to take up much more of your time. So we would like to come back to Indian academia and its opportunities for students. Can you tell us about the opportunities that are available to high school and undergraduate students to contribute to academia at their own level?
Yes. So my view in this regard is a little bit different from what most people have. I get any number of emails and messages asking for internships. And most of these are coming from undergraduate students. And occasionally they're coming from high school students also. Now, what is happening is that if you want to do research research is happening at the frontiers, right? It's happening at a level where people have spent 20, 25 years of their life becoming experts in something, and then they are trying to further their research in that particular area. You can't do an internship with them that will benefit them. You can, as a high school student, you can always do an internship that will benefit you. However, most scientists are very reluctant to offer this internships to very young students because they are, they just need to start from the very basics, right? And it takes them, many of these intern students want to work for some 4 weeks or something, and they want a certificate that will help them further their career. Nothing wrong with that, but it is really impossible for us to teach you anything useful in 3 or 4 weeks. So my advice to these very young students is that, yes, please come to us at the master's level or at the PhD level. We'll be happy to work with you, train you, and so on. But please don't approach us when you're very young. If you're in 10th or 11th, you are better off. So I point them to books. I even point them to courses that are there available on online platforms like Coursera and EDX and so on. And sometimes nowadays even YouTube has excellent content on various aspects of the field, and they can use that opportunities to train themselves. Once they're sufficiently trained, then they can come to us, because then it becomes worth our while also. That suppose I spend a month training somebody, then that person will be so productive and they will give me back more than what I have got. So I don't encourage very young students to do it. This is a particular problem in India, that everybody wants to do things at a very young age. This is very peculiar. I don't understand. This is like nowadays people will advertise that in primary school they will start computer programming. Okay, this I don't think is very healthy, because your brain is not sufficiently developed at a very young age to grasp these complicated ideas. You have to give it time. You learn it, but you learn it at the right time. So for very young people, I say that first identify whether your interest in the field is a passing interest or it's a serious interest. Once you identify that, yes, this is my serious interest, then train yourself in that area. Okay, use material that is available. Numerous textbooks exist. Numerous other kinds of books exist. Material exists on the internet. Train yourself and then decide whether you want to go further in that.
All right. Again, I want to ask about the differences and when a student applies to university abroad and a university in India. So normally in India, you have entrance exams and you can get placed to universities through that. But universities abroad, they ask for your holistic development, right? And most of the top universities, they want you to have done something that was very useful. And like you said, many professors don't want to offer internships because obviously we can't provide them something useful to them. So do you have any other opportunities that students can take part of, such as competitions or any other courses that are being run by some great companies? Some companies also offer competitions, hackathons or something that at your time in Princeton you found would have been very helpful to a student to get into those universities abroad.
So one of the things that we do conduct, like my own institution, NCRA, we conduct an annual competition, which is a project competition. So the idea is to come up with some scientific project based on what you know that would have some impact on society. Okay, so some people come up with an idea for a sewage treatment plant or a battery recycling facility or a garbage to energy conversion facility and so on. So we have this kind of competition at all levels, going from really primary school all the way to undergrad college education. And that competition runs on the occasion of Science Day, which is celebrated on 28th February every year in India, in honor of C.V. Raman, who first demonstrated the Raman effect. So we run that kind of competition, and students are welcome to participate in those competitions because those are designed to be scalable. So we never reject any student who wants to come up with an idea. All ideas are welcome. The best ideas are awarded a prize and so on. So it may help if you win a prize in this kind of intense competition. That would certainly help students who are applying abroad for their college education.
All right, that's great. I'm sure our viewers would want to take part in that. Since we don't have much time left, I would like to ask you one last question. Do you have any advice for us, the New Delhi Space Society, to support people who have a passion for space and astronomy to, increase their skills and abilities?
Okay. So one of the things that I found is useful is that maybe running an online course on some aspect. Okay. Telescope making is a tough course to run online because you can't give real guidance, hands-on guidance. But just an introductory astronomy course which can be run online, inviting experts from outside as well. So here in Pune, the Jyotirvidya Parisamstha runs something like this every year. They call it the basic astronomy course. And they have a series of lectures spread over a month or so. It's not very intensive. I think there is about, one lecture a day, every day for about a month. And they have participants not just from India, but from several foreign countries. They cover many different topics. They have experts in the various fields who can give lectures. So if you do a course like that, of course, you have to first do a market survey. You have to figure out whether there will be sufficient interest in such a course. But if there is, then that is something that people can really use to sort of satisfy their curiosity while also increasing their level of scientific knowledge. And this could be done, I mean, we do it in astronomy, but this could potentially be done in any field. And if it's done online, then many more people can join it. I think that would be, I don't know, what are your current activities in the society?
For the society, we were planning a course, like you said. Apart from that, we mainly organize competitions at the school and college level. We've done one at DPS RK Puram that invites students from all over the Delhi NCR region. And we also hosted a competition at Triple IT Delhi last year. And we participate mainly on the outreach. We have a newsletter that comes out monthly, and we also post articles on Medium.
Okay. Do you do night stargazing programs?
Not yet, but we would like to try. But the issue with Delhi and Gurgaon, for that matter,
No, you have to go out, you have to travel some distance. Yes.
And again, related to that, we've seen youth participation increase in astronomy over the past few years, but it isn't still up to the level of the countries abroad, such as USA and UK. So how can India in general, as well as us at the NDSS, help enhance youth participation in astronomy?
Okay, so that's a tough question. And we realize that we as professional astronomers realize that if we are to make good use of the next generation of big instrumentation that we are now building, like the SK Observatory, we absolutely need to train the next generation of astronomers. And recognizing this, we have in place a systematic human resource development program. So, for example, in this project, we have right from public outreach to education of PhD students, all sort of target audiences are catered through different programs. These programs will start in the coming years. And the hope is that by 2030, when the telescope construction is completed, by that time, we will have a systematic program in place. At that time, we will need partners. So some of the more advanced trainings and workshops and so on, those we will definitely do ourselves. But things that need to reach out to the larger audience, to the public, they will need collaborations. And similarly, other astronomy institutes in India are also looking for partners who can help grow their outreach programs. So I think certainly in the area of outreach and in school education, these are the areas in which groups like yours can definitely contribute. There is also wanted to mention one more thing, that the IAU recently established the Office of Astronomy Education. So this office, which is headquartered in Germany, has been tasked with producing high quality astronomy materials for use in schools. So this education is primarily restricted up to high school, but the goal is to sort of develop this worldwide. And there is a regional node of this Office of Astronomy Education that has been set up in India, and they are also interested in catering to the requirements of the school audience. We have in our country the largest number of school-going students in the world, and we have a responsibility to make them aware of the latest developments in science and technology and to enable their future participation. So if you people are interested in this kind of work also, so with the SK Observatory, you could work, for example, on the public outreach programs. But if you want to specifically work, say, with school children, then it makes sense to tie up with the Office of Astronomy Education and implement or ideate or prototype or test some of their programs within schools, maybe in the NCR region.
Yes, sir. We will definitely look into that. That seems very interesting. Thank you so much, sir, for taking out the time to be with us today. You've shared some very great insights and knowledge, and we'll definitely go through all of that and produce something that our viewers can look at this interview and definitely take some of the insights that you've shared with us today. So thank you so much for being with us here.
Thank you very much for inviting me into this program.
Thank you.